Welcome to my second class on chapter number 6, Triangles. In this class, I am going to discuss similarity of triangles and basic proportionality theorem. Now, let me take two triangles here. These two triangles will become similar if their corresponding angles are equal. Here you can see corresponding angles are equal and its sides are proportional. That means in the last class we discussed the similarity of polygon. The same way for similarity of triangles, these two conditions must satisfy. So we can write two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Now let us look at the two triangles here. The corresponding angles are equal. Then these triangles can be called equiangular triangles. Famous mathematician Thales gave an important truth relating to the equiangular triangles. That is, the ratio of any two corresponding sides in two equiangular triangles is always same. And it is believed that he had used a result called basic proportionality theorem, now known as Thales theorem, for the same. Now, let us look at what basic proportionality theorem says. Here you have triangle ABC. Now, let me take a point here, that is D. Now, let me draw a line parallel to BC through D. Here, this is the line parallel to BC through D. Let it intersect AC at E. Now let me measure AD, DB, AE and EC. Here AD is equal to 2.17, DB 3.94, AE 2.95 and EC 5.36. Now let me find AD by DB, that is 2.17 by 3.94. 2.17 divided by 3.94, which equals 0.550761, or corrected to two decimal places, you can write 0.55. Now, what is AE by EC? Here, AE is 2.95 and EC is 5.36. When you divide, you will get, here also it is 0.550373. Cut to two decimal places, you can write it as 0.55. That means in this case AD by DB is equal to AE by EC. Let me change the measurement of the triangles. Here, what is AD by DB and AE by EC? AD is equal to 2.61 divided by DB is equal to 4.74. So, which equals 0.550633, or corrected to two places of decimal, you will get 0.55. Now, what is AE by EC? That is 4.61 divided by EC is 8.39. That also is equal to 0.5494, or corrected to two places of decimal, you can write 0.55. This case also AD by DB is equal to AE by EC. Now let me take one more case. Here, what is AD by DB? AD is equal to 4.16 divided by dB is equal to 7.57. So, it is equal to 0.5495. Correct to two places of decimal, you can write it as 0.55. And what is AE by EC? AE by EC is 2.98 divided by 5.4. Here you get 0.5498, or cut to two places of decimal, you can write it 0.55. That means in the all the cases you can see AD by DB is equal to AE by EC. This is called what? Basic proportionality theorem. That means I drawn a line parallel to one side of a triangle to intersect other two sides in distinct points. It divides the other two sides in the same ratio. So you can state the basic proportionality theorem as: if a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Basic proportionality theorem, also known as Thales theorem. Now, how to prove this one? To prove this theorem, you must know two things. Here you have triangle ABC. How do you find out the area of this triangle? You know, area of the triangle, you can write it as half into base into height, half base. Now, here, let me take BC as base. Then height, how will you find out? Let me draw a perpendicular from A to the base BC. Let it be D. So, here, area you can write it as half into base, you can take it as BC into height, you can take it as AD. That is half into base BC into the height AD. AD is the perpendicular from the opposite vertex of the base BC. Now I want to find out the area of triangle ABC with base AC. How do you find it? Here I want to take AC as the base, then opposite vertex is B. Now if you draw a line from B to AC, will it be a perpendicular here? It won't be a perpendicular. So what to do? There is a method. What you have to do is, you just produce the side AC. Now from B you can draw a perpendicular to AC produced. Let it be E. So here you can write area is equal to half into base AC into height D. Now let me consider another case. Here AB and CD are parallel. Now let me take a triangle ABC. Here you have triangle ABC. Now what's its area? Area of triangle ABC, you can see it is 31 square unit. Now let me consider another triangle ABD. Here is triangle ABD. Now let me find out its area. Here you can see area of ABD also 30. Now let me change the size. What you can see, in all the cases you can see its area are equal. So you can say if triangles lying between same parallel and having same base are equal in area. Now let us prove basic proportionality theorem. First, let me draw a triangle. Let the triangle be ABC, A, B, C. Now, let me draw a line parallel to BC, intersecting AB and AC at D and E respectively. So, this you can write it as, we are given triangle ABC in which a line parallel to side BC intersect the other two sides AB and AC at D and E respectively. This is the first step you have to write. Now, what you have to prove, that you have to write as the next step. That is, we need to prove, that is, we need to prove that AD by DB is equal to AE by EC. Now, to prove this theorem, you need to do some constructions. That is, you have to draw a perpendicular from E to AD. Similarly, from D to A. Also, you have to join BE and CD. These are the construction you need to do to prove this theorem. So we can write, let us join BE and CD and then draw DM perpendicular to AC and EN perpendicular to AB. Now, let me consider the triangle ADE. Now, I want to find out the area of triangle ADE with AD as base. So, you can write area of triangle ABC. In short, you can write AR ADE. This means area of triangle ADE with the base AD. So, how will you write it? You can write it as half into base side took it as AD into what's the height? You can see to base AD the height is EN. So half into AD into EN. Now let me consider triangle BDE. Let me take the base as DB. Then what will be its height? Here you can see the perpendicular from the opposite vertex E to BD. It is BD produced, which is EN. So you can write area of triangle BDE is equal to half into base BD into height EN. That is area of triangle BDE. You can write it as half into BD into EN. Now again, let me consider triangle ADE. Here, I want to find out area of triangle ADE with base AE. How will you find out? Do write down. You can write area of triangle ADE is equal to half into, let me take bases AE, then its height will be the perpendicular to AE, that is DM. So this you can write it as half into AE into DM. Now let me take a triangle DEC. Now what is the area of DEC? Let me take EC as the base. Then what is its height? Height represented by the perpendicular DM. That is the perpendicular drawn from D to EC produced. So its area you can write it as half into EC into DM. That is area of DEC. You can write it as half into EC into DM. Here we took the areas of 4 triangles. Now let me find out the ratio of the first two, that is area of ADE by area of BDE, what will you get? Area of ADE by area of BDE is equal to half into AD into EN divided by half into BD into EN. Here half can be cancelled, EN and EN can be cancelled. So the remaining is AD by BD. Now, whatever the ratio of the last two, that is area of ADE by area of DEC, that is area of ADE by area of DEC, that is half into AE into DM by half into EC into DM. Here half can be cancelled, DM and DM can be cancelled. So the remaining is AE by EC. Now let me take area of ADE by area of BDE, which is equal to AD by BD. Take it as equation 1. And area of ADE by area of DEC, that is, which is equal to AE by EC. Let me take it as equation 2. Now let me consider two triangles. Now consider triangle BDE and triangle DEC. What is the specialty of these two triangles? You know DE and BC are parallel, and these two triangles have same base DE. That is, triangle BDE and triangle DEC are having same base DE and between same parallels DE and BC. If it is so, what is the condition? Their areas are equal. So we can write, since triangle BDE and DEC are on the same base DE and between the same parallels BC and DE, area of triangle BDE is equal to area of triangle DEC. This you can take it as equation number 3. Now look at the equation 1, 2 and 3. That is area of triangle ADE by area of triangle BDE, which is equal to AD by BD. This is the first equation, and the second equation is area of triangle ADE by area of triangle DEC, which is equal to AE by EC. Now let us take that LHS. What is the numerator of each equation? That is, here it is area of ADE, here in the second equation also area of ADE. That means numerators are equal. What about the denominator? Here it is area of BDE and here it is area of DEC. Are they equal? Look at the third equation. Area of BDE is equal to area of DEC. That means that also equal. Numerator also equal, denominator also equal. That means LHS are equal. That means LHS of these two equations are equal. Therefore, RHS must be equal. What are the RHS? AD by BD and AE by EC. They are equal. So we can write. Therefore, we can write from 1, 2 and 3 AD by BD is equal to AE by EC. That is basic proportionality theorem. That is, if a line drawn parallel to any side of a triangle to intersect, the other two sides in distinct points, then the other two sides are divided in the same ratio. So this is an important theorem. Study. That is all for today's class. Have a nice day.